Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we're going to learn the end of lesson number 8, which I call lesson 8 part 3. And just to kind of detail for you what we have learned so far will help you to absorb what this lesson is going to be all about, because you're probably looking at all these problems going like, well, that's a lot of problems there. So far what you have learned to do is basically you started off simple in mathematics. You learned what is x multiplied by x, right? You learned that that's equal to x squared. Then you learned something like what's x multiplied by x plus 5, right? And so you learned that that's equal to x squared plus 5x, something like that. Then you learned something like what's x plus 2 times x plus 5, and then we developed something called the FOIL method and different kinds of methods. So we came to the conclusion that that's equal to x squared plus 7x plus 10, right? And then you learned a whole different kinds of formulas. You know, what would it be if x plus 2 was whole squared? And we discovered that that's got its own formula, right? Which we called the square of sums formula, and that was the quickest way to go about it. Then you learned something like x plus 2 to the power of 3, and then that became something like the cube of sums formula, which you can see right over here, and that we've learned as well. So uh, you learned different kinds of ways to go about it. Like, let's suppose if it said x plus 2, x minus 2, then this became the difference of squares formula, which is right over here, except it's written backwards as we've talked about before. So really we knew that that was going to go back to a squared minus b squared. Um, and so you've learned a whole lot of stuff about really multiplying, right? You've learned a lot of things about multiplying polynomials, right? Realize that. And so after that, we talked about in this previous lesson something about dividing polynomials. And the two techniques of dividing polynomials were essentially the long division technique and the synthetic division technique, right? So what was really happening is we were really taking the end result, something like x squared plus 7x plus 10, right? We were taking x squared plus 7x plus 10, and we were dividing it by, let's suppose, x plus 3, right? And then we were going about that in one of two ways, either long division or synthetic division. And they had different criterias for that. So that was dividing polynomials, right? Of course, before all of this was adding and subtracting polynomials. And adding and subtracting polynomials, that's seems like a thing of the past. It seems so much easier after a lot of the things that we've had to do now, which was simply just adding like 7x and plus 5x, you know, or 7x squared plus 5x squared, right? So that was adding and subtracting polynomials. So we're essentially done in taking a polynomial, right? All of this is basically taking polynomials and just kind of working with them in different sorts. Sometimes it can be to expand a polynomial, sometimes it can be to simplify, right? Sometimes it can be to simplify a polynomial, like for instance, adding and subtracting was simplifying those polynomials. Multiplying was more like expanding that polynomial. So we've done, and dividing kind of takes a class of its own. It's more tied in with the new topic that we're going to be learning today. Um, but basically, what we're going to be doing now is we're going to learn to do something called factorization. And this is arguably the most important topic in algebra when it comes to working with polynomials, is to factorize a polynomial. And in factorizing a polynomial, think of it this way. It's really the opposite. It's really the opposite of expanding a polynomial, right? So it's the opposite of expanding. And so if you want to think of expanding a polynomial as multiplying polynomials, think of factorization as somewhat of an opposite of, of multiplication of polynomials. Now you're probably wondering, what about division? And that's what I mean to say is division is somewhat of a factorization anyway, all right? So I'm going to be teaching you a whole lot of rules about factorization today. And one of the first things that I'll tell you is basically you look for what's in common. Okay, so as we go through tons of questions today, what you want to keep in mind is he keeps starting with asking the question, what's in common? All right. Another thing that we'll do is we'll count the number of terms, right? So we'll count the number of terms, and based on the number of terms, we'll try different kinds of techniques to factorize. All right. If, for instance, if we end up with 2 terms, right? If we end up with 2 terms, we'll try to see if we can use something called the a squared minus b squared formula, which we learned as the difference of squares formula. We'll try to see if we can use the a cubed minus b cubed formula, which is called the difference of cubes formula, right? But we'll try our best with 2 terms to see what we can do with them. Let's suppose that there are 3 terms, right? If there's 3 terms, almost always what this leads to is basically factoring a quadratic, right? So factoring a quadratic. And in factoring a quadratic, it's not guaranteed it's always going to be quadratic, but usually what that one technique that we have of factoring a quadratic is what we can try doing is something that we've done many times before, is you multiply. So if you have ax squared plus bx plus c, you multiply a and c and you look for the 2 factors that will add. So a factor here and a factor here that's going to add up to b, right? So that's 3 terms. What if it's 4 terms, right? What if it's 4 terms? Then we're going to try something called grouping, right? That's almost the same exact technique every single time as we try. So different tools I'm giving to you. These are different tools that we'll consult, and we'll be like, okay, is this a good instrument to use to factor this term right here, right? And basically, this is factorization in a nutshell. The whole purpose is before, when you used to say x plus 2 times x plus 5 is equal to x squared plus 7x plus 10, that was called the multiplication of polynomials, right? That was called multiplying polynomials. Now what we're doing is we're factorizing. In other words, we're going back the other way. And for many students, going back the other way, right, that factorization, that takes a lot more like thinking and critical thinking. And I will do my best to give you so many examples that you have a good number of things in your pocket to deal with this process of going back from a form that looks like this back to a factored form, right? So this piece right here is usually called the factored form of the problem, right? So that's the factored form. Whereas this right here, you might want to call it a standard form, right? Which is something that we've talked about before. So I wanted to just take the first, 10 minutes of this lecture. It's probably going to be a long lecture, but I wanted to take the first 10 minutes just to kind of make sure that you have a sense of where we're going with these problems. We have quite a lecture ahead of us, so let's go ahead and get started. The first one I want to try is number 74. And number 74 says that you've got x squared minus 9, right? So you've got x squared minus 9. And in x squared minus 9, basically, you got 2 terms. All right, so number 74, x squared minus 9. Notice that you have 2 terms. But before even doing that, you got to look for what's in common. Do you see anything that's repeated in x squared and 9? And you don't, right? So then you go to a formula that we have learned in the past, and we're going to relearn. So look here. The formula says if you ever have 2 terms and you can write them as a square, then you can go ahead and factorize them like this, a plus b, a minus b. So let me demonstrate to you. So what I can do is I can say x is squared like that, and 3 is squared like this. So what that does is it changes x squared minus 9 to a rewritten version of x to the power of 2 and 3 to the power of 2. And now this looks exactly like our a squared minus b squared formula. And the a squared minus b squared formula says that whenever you have something that looks like that, you can automatically write it as a plus b, a minus b. And some students say a minus b, a plus b. That, 2 times 3 and 3 times 2 is the same thing. So in this situation, the answer that you get is x plus 3, x minus 3. And I'll just say a kind word here. If you ever want to check your work, right? If you're like, wait, did I factorize this correctly? I'll try to say this as less as possible because I tend to say it a lot when I'm doing these lectures. But what you want to do is if you want to check your work, you can always take x plus 3x minus 3 and ask yourself, does it lead back to the question, which was x squared minus 9, right? So what you would end up doing is you would end up using the a plus b, a minus b the other way, and then you would be convinced of that. Okay, let's try the next one. Number 76 says 3 minus 27x squared. So number 76 says 3 minus 27x squared. All right, so let's go ahead and look for what's in common. Before you look for squares, let's look for what's in common. Do you see anything that is common between 3 and 27x squared? And if you don't understand, what do you mean by what's in common? By common, we mean that can be divided out from both terms, right? It can be divided like a greatest common factor sort of a thing, right? And so the conclusion that you should reach is actually, yes, there is something in common, and what's in common is the number 3. So when you say that, here's what happens. You end up with 3 multiplied by 1 minus 9x squared. Remember, everything is working backwards now, and at any time, if you want to make sure you're doing it correctly, just say, well, is 3 times 1 really 3? And it is. Is 3 times negative 9x squared really negative 27x squared? And yes, it is, right? So really, just like dividing polynomials, what we're really asking ourselves is, what's 3 divided by 3? Okay, 3 divided by 3 is 1, and that's why I wrote the 1 right there. And then we're asking ourselves, what's 27x squared divided by 3? And that's equal to 9x squared. And that's where I got that 9x squared from. But at some point, your mind just kind of does that division by itself, and you don't have to sit there doing tons of this side work, nor do I need to see that side work in your factorizations. No teacher will ask you for that, right? Now, you might be thinking, well, is that it? Are we done with it? But what I want you to do is I want you to focus on the inner part of this question. And what I mean by that is focus on this piece. So one of the things that starts to really drain you down in factorization is initially it looks like, okay, it's over, I'm done factorizing it, and then it turns out it's not quite over yet. What we can do is we can actually say that 1 minus 9x squared is really 1 squared minus 3x squared, like that. And the reason why I did that just now is because then I can say, well, isn't this of the format a squared minus b squared? And if it is of the format a squared minus b squared, that means that 1 minus 9x squared can be broken down even further. So here's how you break this down further. The a minus b, a plus b formula is right next to you, right here, right? It says if you ever have a squared minus b squared, it factorizes into a plus b, a minus b. So what you can do here is you can say, all right, so now what I'll do is I'll write this as 1 plus 3x, 1 minus 3x. And what you've essentially done is you've factorized it into a plus b multiplied by a minus b. And initially this will just kind of be very different to you. It'd be like, and especially if you've never done these before, you'd be like, wait, how did you figure that out? I didn't have to do too much work. Okay, so anything that's of the format a squared minus b squared, and you can write it that way, you can go ahead and break it down into a plus b, a minus b, where the value of a is 1 and the value of b is 3x. And just another note for you, the problems, they do get a lot easier as you start getting used to this skill. And remember, you're always welcome to check your work, and you'll find that it goes back to the original question as long as you multiplied it correctly. Okay, let's go ahead and try number 80. Number 80 says x squared minus 6x plus 8. All right, so I think this is the kinds of factorization that we even used a lot in geometry. Even though we didn't formally learn it, but I think you guys, a lot of you had said that Sister Reem had taught you this question. So x squared minus 6x plus 8. Well, first off, let's count the number of, well, let's see if there's anything in common between all three terms. And remember, seeing if something is in common is to ask yourself, is there something that can divide out from all three terms? And there is not. So the next thing that you do is you basically say, okay, let's count the number of terms, and there's 3 terms. And so when there's 3 terms, what you're going to do is a different technique, right? You're not going to look for a squared minus b squared. That's useless because that's for 2 terms, right? So what you're going to do is you're going to say, all right, we're going to multiply a and c, all right? So officially, a is the value 1 and c is the value 8, right? So multiply a and c, and you end up with, now I know everybody in the class knows how to do this. I'm just giving you an official technique to do it. So 8, you're looking for 2 factors of 8 that'll add up to -6 but multiply to +8. And you probably thought of these factors a long time ago, so I'm going to go ahead and write them. So you end up with -2 and -4. And as soon as you get those factors, you can write down x minus 2, x minus 4, and you once again are done with factorizing this, right? So that was so easy because you've learned this before. Otherwise, that in itself takes quite a while to convince students how that works. All right, let's go to another question. Bismillah. So the next one that I'd like to try with you, let's go to number 90. And number 90 says 3y cubed minus 18y squared minus 48y. So number 90 is 3y cubed minus 18y squared, and then that's minus 48y. Okay, so let's go ahead and give this a shot. First thing that you want to do is you want to ask yourself, is there anything in common between the 3 terms? And I'll keep reminding you that because one of the things that happens is you see 3 terms and you forget to look for what's in common, and then that comes back to bite you in the end. So look at the first term, the second, and the third. And in fact, there is something in common. And what's in common is you have a 3 that can divide out in the first term, the second, and the third. So we're going to take a 3 out of this problem. And when I say take out, what I mean by that is factorize. Now notice how the first term has 3 y's, the second term has 2 y's, and the last term has a single y, meaning all 3 of them have at least a single y in common. So I'm going to factorize out a y from here as well. Now what do I have left over when I do something like that? Now I'm going to have 1y squared, or just simply a y squared, minus bismillah, 6y, and then at the end I will have minus bismillah, 48 divided by 3 is 16, so minus 16, and it looks like that right there. And remember, if you want to check your work and make sure you did it correctly, ask yourself, is 3y times y squared really 3y cubed? Yes, it is. 3y times -6y, is it really -18y squared? Yes, it is. And you can check that. And I do that, sometimes just to make sure. But I do it in my head. I don't necessarily need to write it down, and neither do you. Okay, now what we're going to do is we're going to look on the inside. Always remember to look on the inside of the problem before you stop and you're like, okay, I'm done with factorization, right? Look on the inside again, right? I'll keep repeating that for you. And so I highlighted for you in yellow. Now, what does the inside look like? The inside looks like 3 terms again. And this time you want to ask yourself, is there anything left in common in those 3 terms? No, there isn't. However, before we stop, ask yourself, is a times c, which is going to give you negative 16, does it have two factors that when you add them you get negative 6, but when you multiply them you end up with negative 16? So try these. What about 2 and 8? Right? 2 and 8 with a negative on the 8. So what I mean to say is really you can break down y squared even further, because 2 times negative 8 is negative 16 and 2 plus negative 8 is negative 6. So you can break down the yellow highlighting even further and say, now I've got the answer y plus 2, y minus 8. And all the time we get the question, can I write them in a different order? Yes, you can write them as y minus 8 times y plus 2. That's perfectly good as long as you have that answer. So now this has happened twice in the last 4 questions where it wasn't quite over. You had to look on the inside of the parenthesis to see if it goes further. And you're going to see that a lot more as we go through these questions. Number 94, it says 8x squared plus 6x minus 2. So let's try it over here. Number 94, 8x squared plus 6x minus 2. All right, so now you want to go ahead and take a look at those number of terms and see if you can find anything in common between these 3 terms. And if you do that, and you do it properly, you'll realize, yes, there's the number 2 in common. The number 2 can divide out in 8, 6, and 2. And so now, really what you have is, you have 4x squared plus 3x minus 1. Remember to check your work to be sure that you're doing this correctly, which means to just go ahead and quickly multiply in your head and say, is this correct or not? Now, again, we are at this stage where we've got 3 terms on the inside. And what you want to do is really quickly, you want to multiply the a and the c. In this situation, the a is 4 and the c is negative 1. You want to multiply those two, and you want to see, is there a way to work with this problem where you have a negative 4? Is there 2 factors of negative 4 that will multiply to negative 4 but add up to positive 3? So you can pause and check, and the factors that we really get are negative 1 and positive 4, right? Because negative 1 times 4 is negative 4, and negative 1 added to 4 gives you 3. Now, what do you do in this situation? Here is where things start to get a little bit more complicated. You cannot conclude. Here is the wrong conclusion. Let me write the wrong conclusion for you. The wrong conclusion is to say that this is x minus 1, x plus 4. You can't do that anymore. And let me explain to you why. All right, so this right here is the wrong conclusion. I generally write wrong conclusions to emphasize that it's a wrong conclusion. You cannot use this technique. All right, you cannot use this technique. If you want to call it a technique, it's really just a trick. You can't use this trick when that front value, which is a, is not equal to 1. If the front value, which is a, is not equal to 1, remember the a was 4 in this situation, you can't do this anymore. Right? And I believe we've talked about this previously. So let's take a look at number 80 here. In number 80, a was 1, and that's why we were able to make that conclusion. In number 90, a, where's a? A is right next to the y squared, right? So a was 1, and that's why we were able to use that trick. But in number 94, a is not equal to 1. A is actually equal to 4. And so now we need to use the proper way of factorization, right? So how do you properly factorize? So let's talk about that. What you do, I'm going to make a bracket here, is you basically rewrite 3x as the following. So you take the 4x squared and you keep it the same, but you rewrite the 3x with those factors that you had found, and the order does not matter. So you can write them with their signs before them as positive 4x minus x or minus 4x plus 4x. It's your call, right? And so we keep the first and the last terms the same, right? I'm keeping I'm keeping the 4x squared the same, and I'm keeping the minus 1 the same. Essentially what I'm doing is I'm taking the 3x and I'm splitting it into these two terms right here. Now, what do you do after that? Basically, now what you have is the issue of factorizing 4 terms, because there's 1, 2, 3, 4 terms. Now, when you have 4 terms, I detailed this for you in the beginning part of this lecture, right? I said that we're going to have techniques to go about things. And when you have 4 terms, what we generally do is we use the idea of grouping. Now, what is grouping, right? What is grouping? How exactly do you go about grouping? Because this is one of the most missed questions by students. They don't exactly know what to do in that situation. So watch carefully. Basically, what you do is you'll take 1 and 2, and you'll take 3 and 4, and you'll copy that addition sign. Okay, so let me just make sure that that's not missed. So we're going to copy that addition sign. So the addition sign is certainly going to be here. In groups 1 and in the group that has 1 and 2 in it, the terms 1 and 2, what do you see that's in common? Right? So what's in common here? What's in common is an x. And what's left over is a 4x minus 1. Need to check your work? By all means. X times 4x is 4x squared. X times 1 is minus x. So that's working for us. Now we copied that plus sign already. What's in common between 4x and 1? And be cautious of saying nothing, because that's not true necessarily. There is a 1 in common between them. 1 can divide into any number. So now what we have is 4x minus 1. And as I used to tell you in class, every time this would ever show up in geometry, which is a rarity, this is not a coincidence. It was supposed to look like this. So now what you realize is, looking at the 2 terms that we have 2 terms here, right? We have term number 1 and term number 2. Notice that in term number 1 and term number 2, there is something that's in common. The 4x minus 1 has been repeated in both of the terms. So what do you do when you see something in common in factorization? You pull it out. So when you pull out the 4x minus 1, here's what it looks like. 4x minus 1. And then you ask yourself, in group number 1, what's left over if I remove the 4x minus 1 and bring it outside? Now what's left over is just simply this guy right here, the x. So what's left over in that first term is only just the x. So the x is going to show up right here. And what's left over in the other term is the plus 1. So the plus 1 is going to show up right over here. And like that, we are done factorizing this. And generally, once we're done factorizing it, we take that bigger bracket off, and we write down 2 times 4x minus 1 times x plus 1. And that is the final factorization that we have for this problem right over here. Now what we're going to do is we're going to try some slightly more difficult factorization problems, and you're probably thinking, wait, it gets more difficult. So yes, initially it gets a bit more, because we got to teach you all the tools that you can use, and then it starts to relax a little bit, and you realize there's a lot of patterns going on here. So the next one that we want to try is number 96. Number 96 says x to the power of 4 minus 1. Now, initially, you'll say there is nothing in common between the two. And you're correct. There is nothing in common besides a 1 between these 2 terms. And then it's just like, okay, what do I do now? So recall that we said that when you have 2 terms, try the a squared minus b squared technique. But one of the things that happens is students tend to think that only when a term is squared, like x squared minus 3 squared, and 1 squared minus 3x squared, then and only then can you use a squared minus b squared. That's actually not true. This formula is very powerful. It's one of the most used formulas when it comes to calculus and factorization. What I can say is, isn't x to the power of 4 the same thing as x squared squared, right? And isn't 1 the same thing as 1 squared? So because I just managed to do that, I made it look like the a squared minus b squared formula. And if I can make it look like that, then I can also go ahead and factorize it according to what I've learned about a squared minus b squared. I can write down in the format of a plus b, a minus b. So in this situation, the a is actually x squared. Try to wrap your mind around that. The a is actually x squared, and the b is actually 1. So this becomes x squared plus 1, x squared minus 1. Now remember the thing that I told you in the previous couple of questions. I said, always look on the inside. Always look on the inside. When you think you're done, look on the inside and be like, is there anything more that I can possibly do to factorize this? And you'll realize that you run into a loop here, right? Because that first term, no, there's nothing that can factorize x squared plus 1. As much as it looks like that, there is actually no formula. There's no such thing for this one right here. So there's no such thing as a squared plus b squared. So there's no formula for that, right? However, this other one, there is a formula for it, in fact, and you just used it. You just need to use it again. And what I mean to say by that is you can rewrite that second parenthesis as x squared minus 1 squared. Now this is a step that nobody really shows, because if they've thought of it this far, then they also have figured out how to solve it, right? So now we're not focused on this left parenthesis. We're looking at the right parenthesis. We're going like, wait, x to the power of 2 minus 1 to the power of 2, that's again a squared minus b squared formula. So you run through this again, and the difference now is, notice how in the beginning the a was x squared and the b was 1. Now the a value is x and the b value is 1, right? Because it's supposed to be a to the power of 2, b to the power of 2. And now what we can say is, well, now I can break down that right parenthesis a little bit further, and here is its breakdown. I can write it as x plus 1, x minus 1. Like this. And so what has essentially happened here is the rightmost parenthesis, which was this one over here, right, which was this one over here, now has been broken down even further, right, to look like that over there. And once you get to this result, you are welcome to look inside of each one of those parentheses, and you'll find that there's nothing more that you could do with them. And so, in fact, the final factorization of number 96 actually ends up looking like this over here, right? What was the secret? Look on the inside of your factorization and make sure that you've figured out everything that could have possibly happened. All right, number 98. Number 98 says x to the power of 6 plus 2x cubed plus 1. So the first thing that we learn in factorization, and that we practiced now what seems like a while ago, is making sure that there is nothing in common between the three terms, right? So you're looking at these three terms and you very quickly conclude, yeah, there's nothing in common there. Now the next thing that you want to realize is, well, this is three terms, right? Now what is the only thing you know how to do with three terms so far? You know how to multiply what's a and c. But there is something more here that perhaps you don't see just yet, right? You have to look at it a little bit carefully. And one thing you'll realize is, in fact, that doesn't say x squared. That actually says x to the power of 6. And this doesn't say x, this says x cubed. So what I'm going to do for you here, right, I'm going to show you how you can still use that same technique to work with this problem. So I'm going to do a parallel problem for you. Right? I'm going to do a parallel problem for you. And what I mean by that is I'm going to write down x squared plus 2x plus 1. Now you don't need to do this to solve the problem. I just want to show you why I'm about to do what I'm about to do. So if you had gotten this problem that is in green, what would you have done? Right? What would you have done? You would have said, well, I'll take the 1, because the 1 multiplied by the 1 on the x squared gives me 1. And the two factors of 1 are 1 and 1. So that's a lot of 1's right there. And because there was a 1 on x squared, I can conclude that the factorization of this is x plus 1, and I'm done, right? That was a two-step problem. All I want you to realize is if you ever noticed that the numbers that you have on the x at the front and the x in the middle, all right? So those two terms. If you ever notice that they are in a ratio of 2:1, so 6:3, are they in the same ratio as 2:1? What I'm really saying is 6 divided by 3 equal to 2/1? And it actually is. As soon as you realize you can do that, all the techniques of factorization of three terms actually apply. So use same technique, right? Use same technique as the one that we just showed over here, right? Just to keep things short. All right. But what's the difference though, right? What's the difference? How do you somewhat change things as you write it? So let me show you. First off, you write down that you still have 1 and 1. You still have plus 1 and you still have plus 1. Right? That's the factors that we got. So it's still plus 1 and plus 1. So you could have asked yourself the same question here. 1 times 1 is 1, and those two factors of 1 that add up to 2 are 1 and 1. So there you go. I've got the plus 1 and the plus 1. What's different, however, is the following. You need to write this as x cubed plus 1 and x cubed plus 1, like that over there, right? And you're probably wondering, is there more we could do with that? So just pause on that front right now and understand why we do this. Is before, when the middle term was an x, that's why we used to put x's in this spot. Most people don't realize that until this lesson. And now, because there was an x cubed in the middle, now we have an x cubed here, and we have an x cubed here. So initially, it looks like, all right, we're done with this, because that was already, a bit of work. But look at how much work I really had to show, though. This is really one step, as soon as you realize that you can use the same techniques. Now, what's the next thing that you do? For this, we need to take a side note, and we have to talk about a formula that is, by the way, in the formula sheet, right? So I've got the formula sheet handy right over here. And that formula is called the sum of cubes formula. It says a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. I know it looks a whole lot similar to some of the other formulas that we've learned, but this has its own name and it's got its own space, right? It's very new to you because there was no such thing as an a squared plus b squared formula, but there is something such as an a cubed plus b cubed formula. So this is a special situation where what we have and what we're looking at is of the format of a cubed plus b cubed. And if you don't see it just yet, think about it this way. Can't you write x cubed as x to the power of 3 and then 1 as 1 to the power of 3? And because you can do that, right? You realize, wait a minute, you can actually go ahead and factorize both of these even further, right? Even further. So what we're going to do is we're going to go ahead and factorize each one of them. And of course, whatever that first one is going to factorize to, the second parenthesis will also factorize to, right? So let's go ahead and start with that first parenthesis. And I just want you to realize where we're going with this. So we're going to be taking this first parenthesis and we're factorizing that, okay? All right, what do we get when we factorize it? Bismillah. Using the formula that I just showed to you, and I'll write it for you here so I can help you fit it into the space. A cubed plus b cubed formula, right? It says if you ever see something in this format, it actually factorizes into a plus b times a squared minus ab plus b squared. It takes a little bit, but you can memorize that. In this situation, the value of a is x and the value of b is 1. And that's why it looks like a cubed minus b cubed. Oh, sorry, a cubed plus b cubed. And that can be repeated for the other parenthesis as well, but we'll talk about that in just a moment, how you don't really have to do too much more work for it. So let's go ahead and apply this formula considering how a is x and b is 1, let's go ahead and write down the formula. The formula says that the factorization of x cubed plus 1 cubed is going to become x plus 1 multiplied by x squared minus x times 1. I'm just emphasizing x times 1 so you understand that it fits into the formula just perfectly like a glove. And then plus b squared, and in this situation that would simply be 1 squared like that. So you have written out the factorization, and just to make it a little bit simpler, this middle term is really x squared minus x plus 1. So here is what you have so far. Now, if you look at the second part of the problem that we had, it was essentially a repeat of the first part of the problem. So guess what? Now what we'll do is we'll take this part of the problem and we'll go ahead and we'll rewrite that same factorization. There's no sense in rewriting the whole thing all together, but I'll write it for you in purple so you can differentiate between the two. So what I'm saying is that second parenthesis can be factorized to x plus 1, x squared minus x plus 1, like this. Now, looking at this very carefully, you'll notice that you actually have a couple of x plus 1's that are present, and you have a couple of x squared minus x plus 1's that are present. It only makes sense because both of these factorize into the same exact thing. So what you can actually do is one final step and you're done with this problem. You can write down that the final is x plus 1 squared because there's 2 of the x plus 1's, and then x squared minus x plus 1 squared because there's 2 of those as well. So look at all the work that we put in, but we are done with this question over here. So I will just kindly remind you that one of the first things that you need to do after you think you're done factorizing is look on the inside and see, can I do something a little bit further? And that's exactly how this thing really ballooned into something that was more enormous, is once we were initially done with factorization, we looked at these two yellow highlighted areas and we're like, wait a minute, you can actually now use a new formula, which is called the a cubed plus b cubed formula right there. All right, let's try yet another example, and now we're going to try number 100. And number 100 says, let's try it over here. Number 100 says x to the power of 8 minus x to the power of 5. Now, so far, you've seen a lot of factorization, but remember the steps always stay the same. First step is look for what's in common. Do you see something that's repeated in both of the terms? And what you have repeated is x to the power of 5. And because x to the power of 5 is repeated, you actually have x cubed minus 1 left over. You may verify that. So you want to look on the inside because that just seemed way too easy. Right, that just seemed way too easy. That's it. You know, number 100, that's all we had to do. So if you look on the inside, you're going to again realize that this is of the format a cubed minus b cubed, right? And so really what you can say is this, it breaks down further into x to the power of 3 minus 1 to the power of 3. And because it does that, I may use the a cubed minus b cubed formula. Now, what is the a cubed minus b cubed formula? It's right underneath the sum of cubes formula. In that previous example, we used the top one because it said x cubed plus 1. In the second case, now we're using a cubed minus b cubed because they're basically two perfect cubes that are being subtracted. Now, what happens in this formula? I just want to highlight for you what's so different about this formula. You want to just look at the signs. The signs are the tricky thing. A cubed plus b cubed has a plus sign when it begins, but it has a minus sign on the second term. Whereas the a cubed minus b cubed formula, it starts off with the subtraction sign, right? It starts off with the subtraction sign, and this is a typo. This is supposed to be an addition sign, right? So I will fix that right away. That's actually a big typo. And then you have an addition sign that follows afterwards, right? So that's the formula for difference of cubes. So having said that, I will write that formula for you down just kind of properly. So a cubed minus b cubed leads to a minus b times a squared plus ab plus b squared, like that. So now that we know this, we can actually say that the factorization can be written as x to the power of 5. Now, if you tend to lose track, just remember a is x in this situation and b is 1, right? And we're just putting those things, those parts, into the formula. It's pretty straightforward after that. So we're going to have x minus 1, so that's a minus b. All right, so that's a minus b. And then we're going to have x squared plus x times 1. And I just do that just to kind of drive that point home, even though that's kind of redundant to write it that way, plus 1 squared. And notice how that fits into the formula, a squared plus a times b plus b squared. So the factorization is good to go. And you can take one more line to just kind of get rid of any extra parentheses or multiplication, sorry. So you have x minus 1, x squared plus x plus 1. And at that stage, you have completed factorizing this right over there. Now, a question that I've gotten in the past, and that's only that if you've gotten this question in your head in the last two questions, then that means you're thinking, and you're thinking well. Did you happen to look inside of this parenthesis and ask yourself, well, what about that? That looks like a quadratic, right? That looks like quadratic. Can't you factorize that further? And that is a brilliant thought. Just think about it. Is there two factors of the number 1, right? Because 1 times 1 is 1. That will add up to 1 and multiply to 1. Can you think of those two factors? And if you're thinking about them and you can't think of any, it's because there aren't any. You can't think of two factors that'll work that way for you. The next question that I'd like to try with you is number 104. So I would argue that after number 100, it actually surprisingly starts to get easier. Okay, it doesn't get more difficult. Believe me, I've been doing this problem set for years, so it's a little bit easier. Now in number 104, it says 5 plus 11x minus 16x squared. So initially that does look like the ax squared plus bx plus c, but it's written in this really weird backwards fashion. It's really written like this. So why don't we do this first? Why don't we first take what is there and kind of flip it around, right? Make it look more proper. So what I'm really saying is, why don't we make it look like negative 16x squared plus 11x plus 5. So let's start with that technique. Right. Now what you want to do is realize that there is a negative sign on the front term. We don't like having negative signs. So I'm gonna put a little note for you. Always factorize. Always factorize negative on the x squared term. All right, so whenever you see that, it's a rarity, but whenever you see that, just as somebody who's getting better and better at factorization, you want to remove that negative sign. And before doing that, did you find anything in common between 16, 11, and 5? And the answer is no, there's nothing in common there. So let's go ahead and use this technique that I just said. Is I'm going to put a negative sign on the outside. So I'm really factorizing a negative 1 if you think about it. And I'll have 16x squared minus 11x minus 5. So if you look at this and you're like, wait, how did those signs change? It's because, remember, we factorized out the negative 1. So is negative 1 times 16 negative 16? Yes, it is. Is negative 1 times negative 11 positive 11? Yes, it is. That's why we switched the signs, right? Remember that time when we said that whenever there's a subtraction sign outside a parenthesis, it causes all the signs on the inside to change? Well, when you pull out a negative, that's going to happen the same way, right? Now we've got 3 terms, and we know there's nothing in common between all 3 terms. But what we can do is we can multiply the 16 and the negative 5 to see where that would take us. So 16 times negative 5 gives you negative 80. Can you think of 2 numbers that will add up to negative 11 yet multiply to negative 80? And those numbers are 5 and negative 16. right? Ironically, they're 5 and negative 16. 5 times negative 16 does give you negative 80, and 5 plus negative 16 does give you negative 11. So now we have a negative sign on the outside. We have 16x squared, right? And you're going to go ahead and write down plus 5x, so plus 5x, minus 16x, like this over here, and then minus 5. So earlier in a problem I showed you how you don't change the first term and the last term when you're factorizing quadratic. So we did not change the first and the last, but that middle term, that in negative 11x, I rewrote it as 5x minus 16x. And you do realize 5x minus 16x does give you negative 11x, so we just rewrote it into a certain format. So if somebody asks you, well, why did you rewrite it? And you answer to them by saying, now I'm going to make groups out of these two. I'm going to group these, right? So remember, in grouping these, you always copy down that subtraction sign. This always tends to confuse students. Like, what happened to that middle sign? That middle sign just gets copied. So now we have a negative on the outside, and you ask yourself, what's in common between the first group? Between 16x squared and 5x, there is a single x in common, and you're left over with 16x plus 5 from that first group. In that second group, there is nothing really in common besides the number 1. So go ahead and write the number 1 out front. So now you have 16x, and then that is plus 5. You might be saying, wait, what in the world? How did that sign change? A lot of students ask this question, so let me remind you. Negative 1 times 16x is negative 16x. And negative 1 times positive 5 is negative 5, so it does work for you. All right, now we're almost done with this factorization. So in this situation, we have a negative on the outside. We have two things that have been repeated, right? They're in common. So we're going to take that out of the picture, and we end up with 16x plus 5, like this. And then you ask yourself, what's left over? What's left over is an x and a minus 1, and you write that x and the minus 1 in the next parenthesis. And yet again, you're done with factorizing this problem. All right, now we're going to try number, bismillah, 112. All right, so 112 is the next one that we're going to give a shot. Actually, let's try number 108. I see something there. So number 108. It says 4 minus 14x squared minus 8x to the power of 4. So first thing that we're going to do is we're going to write this in standard form. And to write it in standard form is basically what we did in that last question. We start from the highest power, and then we go to the lowest power, or the lowest degree more like, right? Because it's kind of awkward to look at something written from the lowest to the highest degree. Now, there's a handful of things that you can do here. Notice how there is a negative out front on that term that's in the beginning. So what we're going to do is we're going to factorize out that negative, right? Just like we did in that previous example. So now you have 8x. Actually, you know what? Before we even do that, do you see something more than just a negative that you can take out of this problem, and you can take out the number 2 from the problem? So a negative 2. Now what you have is you have 4x to the power of 4, all right? And then on that middle term, you have plus 7x squared. And on that final term, you have a negative, negative 2. All right, so feel free to make sure that that's actually working for you by checking your work, and you will find that each of these does give us what we started off with. Now, look on the inside once again. Look on the interior. Right, so I have kept repeating this over and over, and I think now it's probably getting across to you, inshallah. So on the interior, you notice first off, this isn't exactly the purest form of a quadratic, because there is x to the power of 4 and x to the power of 2. But let me remind you, if those two numbers that are written there are in the same ratio as 2 is to 1, you may go ahead and factorize them the same way that you normally did. So we're going to go ahead and take the 4 and the negative 2, and we're going to multiply them, and we end up with negative 8. Now, what are two factors of negative 8 that add up to 7 those two factors are -1 and +8. So can we go ahead and write down x minus 1, x plus 8, right? We absolutely cannot, and the reason why is because the value of a is not a 1 anymore, so you can't just do that. Well, what do you do next? Now what you do is you say -2 multiplied by, right? I'm going to put a bracket here, 4x to the power of 4 minus 1x squared plus 8x squared, like that, and then minus 2. So notice once again, I'm being very consistent here. I changed only that middle term into -1 and 8, but I kept the first term the same and I kept the last term the same. And notice how it does make sense that this is -1x squared and +8x squared and not simply -1x and +8x, because when you want to put them back together again, they had better be put back to 7x squared. Now that you have 4 terms, you can say, well, I can now group these terms into 2 and 2 and make sure that I copy down that addition sign between the two. So here's what we have now. You have -2. Between the first two terms, you have an x squared in common, so you write down x squared, and what's left over is actually a 4x squared minus 1, like this. And between the next two terms, you have a 2 in common. Between 8x squared and -2, you have a 2 in common, and what's left over is once again a 4x squared minus 1. Now recall I told you that it's not a coincidence. This is how it's supposed to work, that you have the same exact thing that's being repeated right over here and right over here, because it's telling you to do something. What you have to do now is you have to factorize that piece out, right? So I'll remove the bracket now, and I'll write down 4x squared minus 1, and I'll ask myself what's left over when I take out the 4x squared minus 1 from both those terms. I'm left over with x plus 2. So what's left over now is x plus 2. Now, initially you will be like, phew, finally we're done with this. Look carefully. All right, I'll give you a hint. Look at this piece right here. That right there, my friends, is actually -2, 2x squared minus 1 squared, and the rest is x plus 2. That one's fine. What I'm trying to imply here is, in fact, this can be rewritten in a squared minus b squared format. So you see how far this can actually go, right? So you end up with -2, and because a squared minus b squared is equal to a plus b times a minus b. All right, let me write it over here. It's supposed to be a plus b times a minus b. So what we're going to do is we're going to go ahead and write down 2x plus 1 multiplied by 2x minus 1, and that is the factorization of that middle factor right there. The one that's at the end is still going to be x plus 2, like that. And so altogether, your final factorization is right out in front of you once again. All right, the next question that we're going to try, and we're about wrapping up here. There is some other problem sets after this, but not as difficult. Number 112 says x minus 1 whole squared, x minus 1 whole squared minus 2 times x minus 1. Now, remember, this whole technique is about factorization, but what's happened in the past is students have done the following. They've taken this right here and they've expanded it, even though I'm telling them this is the opposite of expanding is what we're doing in this lesson. And they've taken this right here and they've expanded that as well. So they end up going the long way before going the shorter way. And it does work out for them. It actually does work out for them, but it just takes a longer time for them to be able to do this. So let me share with you the technique that they've used in the past. They've said that I can use the a minus b whole squared formula on that front term, and I can get this to look like a squared minus 2ab plus b squared. That's actually true. Let me just mark that in green, right? So let me just mark that in green because that's technically a formula that we're just using there, okay? All right, now, that actually will work, right? That'll work. You could say that this becomes x squared minus 2 times x times 1, so minus 2x plus 1 squared, so 1. And then this piece right here becomes what? It becomes minus 2x plus 2. And then at that stage, you can say, well, I have a negative 2x and I have a negative 2x. So that becomes x squared minus 4x. And I've got a 1 and I've got a 2. So that can be rewritten as a plus 3. Then what they do is they're like, now I'm going to factorize this, not realizing that you could have done this a whole lot easier before. They're like, I'm going to factorize this now. And when they factorize this, they're like, well, the two factors of 3 are going to be negative 1 and negative 3 that add up to negative 4. That's actually true. So in that situation, the conclusion they've made in the past is they said, well, now it's equal to x minus 1 times x minus 3. And what I'm here to tell you is, yes, that is correct, but let me just give you a more quick way of doing this. X minus 1 whole squared minus 2 times x minus 1. Don't forget what I started this lesson with. I know it's going to go past an hour. I realized that before I started, right? But the two terms have actually something in common. What do they actually have in common? They have an x minus 1 that's being repeated in both of the terms. And for that, you have to realize that I had, you have to realize that I actually have two terms. I have term number 1 and I had term number 2. So in those two terms, what you had in common was an x minus 1. So you pull out an x minus 1. And now you ask yourself, in term number 1, if I pull out an x minus 1, how many x minus 1s do I have left over? I actually have an x minus 1 still left over. So like that. All right? And let me put a bracket here just so you understand. So what's left over, when you pull away one x minus 1 from that x minus 1 squared, is you still have an x minus 1 in this spot. And in the second spot, what you have left over is a minus 2. Right? That's all that's remaining over there. So now, in this situation, you want to look at it carefully. You'll realize, wait a minute, x minus 1 is multiplying into x minus 1 minus 2. And what's x minus 1 minus 2? It's actually x minus 1 times x minus 3. So this is actually the quicker way and the proper way, and the reason why they wrote that question, for you to be able to factorize it the way that I just did right over there. The next question that we'll try is number 114. So number 114, it says that you've got 5x plus 1 cubed. And notice how they wrote that. I want you to think about it. Look at how they wrote that there. And then minus 1. Here's what I'm going to do. I'm going to say, isn't this technically 1 cubed? Isn't that the same thing? And if you're wondering, why would you write it like that? It's because, think about that formula, a cubed minus b cubed, which I have taught you how to use in this lesson. And a cubed minus b cubed leads to a minus b times a squared plus ab plus b squared. And so what we can say is, why don't we call 5x plus 1 our a, and why don't we call the 1 our b? So in this situation, here's what this can factorize into. We can write down that I have 5x plus 1, right? That's a, minus b. What's b? b is 1, so minus 1, right? And let me write underneath it. I know it's taking a while, but I'm going to write underneath a minus b, like that. All right? And then that's multiplied to a squared. Now, what is a squared? A squared is going to be 5x plus 1 squared. So 5x plus 1, 5x plus 1 squared, like that over there, right? And then plus a times b, right? So plus a times b would be 5x plus 1 times b, which is simply 1. And then plus b squared, which is 1 squared. So again, just making sure that I have written this out for you in the format that you're accustomed to. Notice that that's a squared, this is a, this is b, and that is b squared right there. So it's looking exactly the way that we need it to. But if you look at what's on the inside of both of these, I don't want to highlight anymore, but if you look at what's on the inside of both of these, you'll realize that in that first set, you can actually cancel out the, you can actually cancel out the 1s, so you'll be left over with something a lot simpler. You'll end up with 5x. Okay, you have 5x right there. And in those middle terms, right, in those middle terms, you will actually have plus 5x plus 1 right here, and you'll have a plus 1 on the other side. So perhaps you could do more with that, right? Perhaps you could do more with that. Let's write down 5x plus 1 squared first off. And you have 5x plus 1, and it's added to another 1. So you actually have plus 5x plus 2, like this, plus 5x plus 2. And at that stage, you may go ahead and stop with this factorization and say, well, there you go. I have factorized this. Remember, don't find yourself expanding anything. Don't say, oh, let me use the a plus b whole squared formula and make this a little bit larger. So then that's spiraling the other way, and the way that we don't want you to go. All right. The last few that we're going to try here is we're going to try number 120. Let's just go to 120 right away. So 120 says that you've got x to the power of 4 plus x to the power of 3 plus x, and then that's plus 1. Right? So initially, that's what that problem actually looks like. Well, do you see anything in common through the entire picture? All right, and the answer is no. We don't see anything in common. Well, what if you were to group, because this is 4 terms, what if you were to group these terms and copy down that addition sign, right? If you were to group these terms, now do you see something in common in those groups? And in that first group, you see an x cubed in common. So get to thinking, okay, this is an x cubed. What does that lead to? And on the inside, you'll have an x plus 1. On the other side, what's in common between x plus 1? There's a 1 in common, and you again are left over with x plus 1. And same exact pattern repeats. Notice that in the 2 terms that you have left over, there is an x plus 1 that's been repeated. So what you'll do is you'll pull out the x plus 1 from the picture, and you're left over with an x cubed and an add 1, right? So you have x cubed and add 1, like this over here. All right, what do you do with that next? And I hope that it's coming to you, is, wait a minute, isn't x cubed plus 1 in the format of a cubed plus b cubed, right? So it's almost never over until you go another step, it seems like, right? So you can say, because that's of the format a cubed plus b cubed, we can further write this one over here as a plus b, right? So x plus 1 multiplied by a squared, so that would be x squared, minus ab, so that would be minus x times 1, and then plus b squared, which is 1 squared. Now simplify that a little bit further, and you'll notice that, wait a minute, I have 2 of the same out front, so I have x plus 1 whole squared, and then what comes after that is x squared minus x plus 1, like this. So once again, we are done with factorizing this as well. All right, this next exercise says that determine the number that should be added to complete the square. So we learned completing the square earlier, and we're basically learning it again. And it says then factor each expression. So we're going to go ahead and take number 122 and we're going to try it, and number 124 and try it. Now I realize that this lesson is taking a very long time, but it's taking a long time for me to teach, right? It's designed so that you learn it and pick it up pretty quickly, and also you can always pause this, do a number of problems that are due, and then go back to it later. And you'll have several days to do this lesson here. So let's start with number 122. What we're going to do is we're going to do something called completing the square. Now here's how you complete the square. I have left in the formulas, right? And now let me go find those formulas. I believe I don't have it on this set just yet. So here is the completing the square technique. I have left for you a way to think about it right here, right? And you are welcome to read up on that. I don't want to explain that to you necessarily because I'm teaching it to you right now, so I'll just sort of just go through it. Go through it very quickly. So here's how you complete the square. You basically add a certain amount, right? You add a certain amount and then you subtract that certain amount. Initially, you'll be like, wait, why would you even do something like that? And you'll see that in just a moment. That amount that you add is always b, okay? It's always b divided by 2 squared. So you always add b divided by 2 squared in this spot right here. And then once you've added that, because you don't want to change the expression, then you want to go ahead and subtract that same thing right in the spot over here. So let's go ahead and do this. If b is the number 14, and 14 divided by 2 will look like this over here. So we add 14 over 2 squared, and then we subtract 14 over 2 squared. Once again, you've definitely done this in my class in geometry. So now we have p squared plus 6p plus 7 squared minus 7 squared. So this is what I mean to say is you didn't change anything, right? You're adding something, then you're subtracting it, so you're good to go. But the reason why we do that is the following, all right? Oops, sorry, I accidentally wrote a 6. That's not supposed to be a 6. That's supposed to be a 14. So this becomes p squared plus 14p plus 49. And what I want you to do is I want you to look at this separately and not subtract the 49, because then you'll kind of lose it there, right? So when you look at these three terms right here, you'll say, oh, okay, I know. I can actually factorize that into the number 49 has two factors, 7 and 7. So I can actually factorize this into p plus 7 times p plus 7, i.e. I can write it as p plus 7 squared, right? P plus 7 squared. Now the rest of that picture, it's still just been 7 squared the whole time. And you're probably wondering why would we have written it to look like that? That's one of the techniques that we use in calculus to work with certain kinds of problems. And that's one of the reasons why you need to know it though. So that's number 122 for you. All right, now let's try number 124. Number 124 is pretty much the same, except it's got a subtraction sign in the middle. So what do? Not a whole lot different. You're supposed to go ahead and add b divided by 2 squared. Now that would be 4 divided by 2 squared, or you could say negative 4 divided by 2 squared. It doesn't really matter because really in the end, that squared makes it a positive because you're adding that, right? And then you subtract that same result. So minus 4 over 2 squared, like this. Now, for the first three terms, here's what you get. You end up with x squared minus 4x plus 4. And then on the other end, you have 2 squared just kind of sitting right there, right? Or you could write it as minus 4. It's really your call. Now, in this set right here, go ahead and factorize that. And when you factorize that, you have 4, and you're looking for two factors that multiply to positive 4 but add up to negative 4, and you end up with negative 2 and negative 2. So now you have x minus 2 times x minus 2, and over here you have 2 squared. And so really this looks like x minus 2 squared minus 2 squared. Or you could write x minus 2 squared minus 4, but that basically is the whole point of this exercise. And it's called basically completing the square in this situation. And finally, the last thing that we're going to try in this lecture is working with expressions that need to be factorized in calculus. Right? They occur often in calculus, so we're going to learn to factorize these. And it was a while back, but I said, remember to look for what's in common between things. All right, that's really your foot in through the door. So we'll try number 130, and we'll try number 136, right? So in number 130, here's what you've got. Number 130 says that you start off with 3x squared, 8x minus 3, right? And you've got x cubed times 8. Now, what I'll ask you is what's in common? Actually, no, before that, how many terms do you have? You have one term, and you have two terms. So now you know what a term is, right? Whenever things are being multiplied, that doesn't make them two separate terms, still one term. What do you see in common between 3x squared, 8x minus 3, and x cubed 8, right? the answer that you should get back is, well, I see that there is an x squared and an x cubed, and therefore I can pull out an x squared from those two. When you do that, what are you left over with in the first term? You're left over with 3 times 8x minus 3. What are you left over with in the second term? You're left over with a single x still, and you have an 8 as well, right? Because you took out only 2 of these x's. You have an x squared, so you still have a single x in that second term. Well, what does that lead to now? If you look on the inside, you can actually go ahead and you can simplify that a little bit. That becomes 24x minus 9 plus 8x. And then that further becomes 24x plus 8x, which is 32x minus 9. And if you didn't think that that was terribly hard to do, well, that's the kinds of factorization that we deal with in calculus, okay? So I don't personally think it's that hard, but, you know, there it is. All right, let's try number 136 right below where it's written, because it'll prevent us from spending so much time in rewriting this problem. So in number 136, there is still only, they're massive, but there's only how many terms? There's only 2 terms here. Oops, sorry. Even the computer's tired now. So there's 2 terms here. Right, there's 2 terms. So now you want to ask yourself, what's in common between these 2 terms, right? So look at it carefully. The first thing that I'll say is there is a 4x plus 5 that's repeated in both of the terms. All right. There is also a 5x plus 1 that is repeated in both of the terms. So that's 2 things that are in common. But then if you look at the numbers very carefully, and the numbers are 3, 4, 2, and 5, really what 3 times 4 is actually a 12, right? And 2 times 5 is actually a 10. Well, let me ask you this. Is there something that's in common between 12 and 10? Yeah, there is, and it's the number 2. 2 goes into both of them. So here is what 136 factorizes out into. You have a 2, and then you have a 4x plus 5. Now, how many should we pull out? Let's see here. In the first term, you had 2 4x plus 5s. In the second term, you had 3 4x plus 5s. So we should pull out 2 of them because at least 2 are in common. Now the same exact logic applies to 5x plus 1. There is 5x plus 1 squared and 5x plus 1. So because there's only a single one that's in common in both terms, we'll pull out a 5x plus 1 like this. And then at that stage, you make a bracket and you're like, okay, what's left over, right? What's left over? Well, in the first term, because initially we had a 12 and now we pulled out a 2, so we have a 6, because 2 multiplied by 6 will still give you 12, so that works for us. So you got a 6. Now how many 4x plus 5s do you have left over? You don't have any because you pulled out both of them, right? You pulled out both of the 4x plus 5 squareds. How many 5x plus 1s do you have left over? You have a single 5x plus 1 still left over. So that's still there. Now let's talk about the second term. In the second term, we had 3 4x plus 5. Well, actually, let's talk about the 10 first. So the 10, if you pulled out a factor of 2 from it, you have still a 5 left, right? Because remember, 2 times 5 will then give you 10. Now let's talk about the 4x plus 5. How many 4x plus 5s do you have left over? Because we pulled out 2 of them, we still have a single 4x plus 5 left over here. And finally, we don't have any 5x plus 1s because the one that we had, we pulled out of the picture already. So that's how crazy finding commons can get. Now, there's a little bit more that we'll do and then we'll wrap up with this lesson. And basically, you want to look on the inside of that bracket and see if you can simplify anything. And you certainly can. Notice that you have 6 times 5x, which is 30x plus 6. And in the other situation, you have 20x plus 25. So you can take the 30x and the 20x and you can add them up and you can say that I have 50x. And then you can take the 6 and the 25 and you can add those up and say you have 31, like this. And so that is the end of the lesson. All right. Thank you so much for listening, and good luck in doing the homework, inshallah. And Assalamu alaikum.